All right, so homework for today shouldn't have been too bad, but kind of proved that you were following along with what we did in class last time. We needed to, so last time we read in from the file all the information about our rooms. Then we read in from the file information about our exits and actually built the exits. Now we need to make sure that the rooms are aware of the exits that they're involved in, I guess something along those lines. Okay, so in order to do that, we need to first teach our rooms how to add an exit. Rooms already hold a collection of exits. Let me go in here. So here is a room currently. So a room has a collection of exits, but we currently don't have a, oh, we do. We already wrote an add exit. So it still is only 2 lines of code. All right, so rooms already know how to have an exit added to them. When we are building an exit, so if we go back to main here, we see what we did last time. If the current mode was exits, we got our parts for our exit, and then we added to our list here this new exit that we are currently building. So what we're going to do here is inside the constructor for exit, as an exit is being built, we will let the 2 rooms involved in an exit know about this new exit. So inside of exit, during the construction of an exit, we'll say destination 1, add exit. So we want to let this room, destination 1, know about the exit we are currently building. This is how an object refers to itself from within itself. So we are going to let this room know about the exit we're in the process of building. Similarly, this dot destination 2, add exit, this. So now both rooms that were involved in the creation of the exit know about the exit that is currently being created. That make sense? So now when we run this, we see that there is an exit to the north. All right, now, my guess is several of you maybe did a little bit more to make that happen. Okay. but this is actually good because this really drives home. I actually see a couple of like pissed off looks. Okay. This really drives home the point of this keyword. And what kind of is a little bit frustrating maybe in this particular case is while I'm in the process of building this brand new exit, I'm letting the rooms involved in this exit know about the exit I haven't finished building. It's almost like the circular type thing. But the point is that even though we are currently inside the code involved in building this particular exit, this is still a pointer to that exit. All right, so I already have the memory address for this exit that's currently being built. And since this exit is effectively going to be a doorway being built, if we use our current example here, like this is one of the rooms called this destination 1, and the hallway is the other room, destination 2. And I'm currently building this door. Inside of the construction of the door, I'm going to throw a pointer to this room, to the exit, to the door. I'm going to throw a pointer to that room, I'm going to throw a pointer to this exit to that room, because both of those rooms are involved in this exit that I'm currently constructing. Does that make some sense? So the key point here is, and we've seen a bunch of examples of this so far, understand the use, the power of the use of the this keyword to allow you to refer to an object from within itself. It won't always be used to talk about one of the fields, one of the instance fields. It can also just be used on how do I say me? Inside my head, I don't refer to myself on a first name basis, right? Okay, or you're talking to other people. You don't say, well, Mike went to the grocery store. You know, that's going to come off as kind of weird. You said, I went to the grocery store. We have a special way of referring to ourselves when we're talking about ourselves. And that's how this keyword works. All right. So questions about this? All right. So last time we moved a lot of that extra build map stuff down in outside of main. So main was fairly clean here. Okay. So what we want to do is we want to go ahead and start building our kind of our game out of this. So once they get thrown into the world, and we can always create more objects. We want to hide this stuff inside of other objects, but rather than do that right now, let's just kind of stick with what we're doing this exact minute. So right now we add the player to the main entrance because we know that entrance is where the dungeon begins, okay? And then we're just telling the player to look around. Now, when we tell the player to look around inside a player, all that player is doing is telling its current room to display itself. All right. Well, now we might want a player to, I don't know, do something. Okay, we want to be able to walk through our world. All right, and that's going to involve having the player start taking some responses. So we can call that method whatever we want. So maybe inside a player, we have a public void. We just call it play. All right, and play is going to continually ask the player, what do you want to do? All right. So we'll just say while true. So forever, until something makes me leave this this world. So when we tell the player to start playing, okay, so they just threw me into this room. We'll pretend like this is the entrance for a moment. They threw me into this room, and now, you know, our program tells me to start playing. Like, okay, well, what do I want to do? So we have to think about some of the things we might do in our game. Our first goal is we should be able to look around. All right. So maybe we have a command just called look. All right. Secondarily, we should be able to take an exit. I might want to, from the entrance, I might want to go to the north. From here, I might want to go to the south. And I want to be able to walk between rooms. Okay. So we need a mechanism for reading stuff in from the user. So I'm going to go ahead and I'm going to create a scanner. And scanner is in java.util, so we need to make sure we import that up here. All right, so now we have our scanner. Remember, we used our scanner to read in our file. We also can use it to talk to our input stream. So scanner reads stuff in from a stream. We can use that same tool to read in from different sources. So we've used it to, well, we originally used it to read in from the keyboard. That's what system.in is. So what we'll do here is we'll just print out to the user system.out.print. I'll go something like that. What would you like to do? And then we're going to read something in. I'm going to go ahead and give myself a string up here, maybe called line. And we'll say line is equal to input not next line. So we'll read something in from the user. All right. And for right now, why don't we just ask the question if line dot equals look. Now, if we wanted to, there is a second version of equals. So we go Java string. There's a version of equals called equals ignore case. So if we wanted the user to be able to type in the commands using different case sensitivity, we could so here's a equals, and then there's an equals ignore case that will treat look in all lowercase to the same thing as look starting with a capital L, if that was something we wanted to support. We could also just kind of go with the normal programming perspective and say, look, if you want to get the right command there, you got to put it all in the lowercase or something, especially if we want to have support for exits that have directions with the same name but a different capitalization. I'm not sure if that's something we'd ever want, or one room could have an exit to the north all lowercase and an exit to the north all uppercase. Maybe that doesn't make tons of sense, but you know, you can decide if that's important to you or not. But just for future reference, there is a version of equals that says equals ignore case that will return true if it's equal in content regardless of case sensitivity. But we'll just say equals here. So if they entered in look, what do we want to do when the player says look? We're going to show them the current room that they're in. So we're going to do the exact same thing as look around. So this dot look around. That's what the player does when they are when they say look. All right, make some sense? So let's go and test this, make sure that we can get thrown into a room and just say look over and over and over again and keep being reminded about our surroundings. So probably, in fact, what I'm going to do is I'm going to move I'm going to go ahead and say show the room we are currently in when we start to play. So just as a starting point, when we tell the player to play, the very first thing we'll show on the screen is the room they're standing in. So that's outside the loop. We just do that one time, and then we ask them, what do you want to do? So now out here, after I've added a player to the room, rather than say, look around there, I'll just tell the player to go ahead and play. All right, so here's the room we're in. It's asking me what we'd like to do. I'll go ahead and type look again. So I can just keep typing look all I want. If I say north, it's not going to do anything. It's just going to ask, what do you want to do? All right, make some sense? All right, so now we want to be able to walk around our map. So we need to treat anything that's not a built-in command. So right now we have one built-in command, and that's the command look. Okay, why don't we go ahead and build a second command, maybe called exit, just for the sake of completeness. So we'll say else if line dot equals exit. Then we go ahead and we'll say something like, you know, goodbye or something like that, and then exit the program. Remember, return makes a method immediately end. This method does not return a value. which is why we haven't put anything after the word return here. Its return type is void, but the return statement is still allowed. Return makes a method immediately end and optionally lets you return a value. So this will make this method end. Similarly, instead of return, I could have said break here. The break command breaks you out of the most recent loop, which then would put us right here after that loop. And then we run to the end of the method and the method ends. Both of them end up running out of runway, and this method ends up, this function ends up ending. So in this case, with the current logic, we can say these guys are interchangeable, but we might want to say that if we needed to have some cleanup logic down here that always happened when we finally were getting ready to leave this function, we might want to break out of the loop rather than return. But in this case, return gets us what we want to do. We're done. So now our game knows how to support two separate things, look and exit. All right, so here we can type look a couple times, and then we type exit, says goodbye, and now we're done. Go ahead. Top of the player profile. Oh. And if you want to look that up, let's say you want to use the scanner class, you would just come out to the documentation, type in scanner, and scanner lives inside of java.util. Yep. So kind of the idea here is rather than having to memorize that kind of stuff, be able to read the documentation. That's the skill that we want to have, because I don't care how long you code in Java, you are, yeah, Ethan. Ethan had put in chat, wouldn't break work as well, and it does. No matter how long you program in Java, you're not going to memorize the whole language. So be able to read the documentation. That's the skill you want. Go ahead.
So when I type look, it'll look, but then it kicks down to that else if.
Okay, well then you wrote it wrong.
Right.
All right, so you're saying when you type in look, it will look, and then it's just dropping down. So is it getting into this?
It is. If I type look.
Check to see if you have a semicolon right there. Is that it? All right, I'll go debug that, but I'm pretty sure that's, I mean, that's the only thing that could be happening is if you're getting to this logic all the time. If I put a semicolon here and I run this and I type in look, it's then going to say goodbye. Yeah. So again, these are kind of common mistakes. You know, when you're a kind of inexperienced programmer, you tend to get semicolon happy, and you just put semicolons all over the place. Same thing with curly braces. No, you never have too many curly braces. You just kind of start throwing them around, right? So good place to look is if you have a semicolon there, then this else if ends right there. This block statement's no longer linked to it. This is just weird code that you happen to have inside of curly braces, but it would be as if these two lines we're sitting right there without any of this. That's effectively the logic that you had. All right. So now we support 2 commands. Then we're going to go ahead and throw in our catch-all, our else. If we're in our else, we must be trying to do movement. All right, so we're going to assume if you didn't type in one of the known commands, you must be trying to take some exit in the room. Now we could make that part of the command. We could say like go north, something like that. But I think that might get kind of frustrating to walk around the map doing that. So let's just treat it as the else. So if we type in a direction, so at this point in time, the line holds something like north. We want to know if that is a allowed exit, right? All right, so for instance, if I'm in this room right now and I try to exit to the north, let's say, okay, that's not a thing. I'm still in the room, right? I'm still in the room, but I didn't take any exit. I slammed into the wall. Well, that's true. It could go out the window. I probably, based on Zenith VR, I probably have enough stamina. I could glide down. All right, so the first thing we need to do is we need to ask our current room, is there an exit in that direction? All right, so let's go ahead and teach room how to return true if there is an exit in a certain direction and false otherwise. Kind of teach it one little part of this this problem, okay? Because that might be helpful in some other things. Sometimes you want to, not solve too much of a problem inside of a single function. You can make the argument of, hey, maybe we just try to take the exit. Like I mentioned, in real life, we could say, well, I'll just try to go to the north. And assuming there's no windows over there, I just slam into the wall and rub my head or whatever. But otherwise, I could decide to kind of glance to the north and say, is there an exit over there? If yes, I'll go ahead and try to take it. Else, I won't. Something like that. So let's teach a room how to tell us whether or not there's an exit in a certain direction. Remember, rooms hold an array list of exits. So I want to go through all the exits in that array list, asking an exit if it has a certain direction leading away from me, right? Because this guy might have directions in it that, for example, might have a direction leading to the north. If I'm in this room, that exit involves this room and the room next to it. So from this room's perspective, if I'm going to go through all of my exits and I say, is there an exit to the north? Technically, that exit right there does involve a direction to the north. It just happens to be associated with the other room. All right, so I need to go through and ask each of my exits, is the direction that you are relative to me equal to what I just typed in? So we need to teach an exit to give a direction that's not to me. Because remember, the way we built exits is we have a destination room, and then we have the direction that leads to that destination. So if I'm already in the destination room, the only direction that I have available to me is the one leading to the other room. Make sense? So we're going to teach exits. Oh, we already did it. Get direction string leading away from the room that we're currently in. Yeah, so this will work. So this guy's going to give us a string that leads away from whatever room I give it. So inside of room, what abilities do we already have in here? Add exit, we get name, okay. So we're gonna go ahead and we're gonna write in room. We're gonna have a public Boolean has exit. We'll pass in a direction. And we want to go through all of our exits potentially. So for int I is equal to 0, I is less than this dot the exits dot size. It's the number of elements in my array list. I plus plus, so we'll go through all of our exits. And then we want to ask this exit, do you have a direction that's equal to the direction I'm checking for, leading away from me? Exits have a get direction leading away from a room function that returns a string. So I'll go ahead and I'll get the current exit. So this dot the exits dot get I, this will boil down to the exit that we're currently looking at. I'm going to ask that exit to get the direction string leading away from a room. What room do I want it leading away from? The room we're currently in. All right. So this whole thing is going to boil down to a string. And we want to ask a question about that string. If that string dot equals the direction we're looking at. I know this line kind of seems like a mouthful, but you got to follow through it. This is the exits get an I, that's an exit. I'm going to, on that exit, I'm going to call get direction string leading away from a room, passing it this particular room. So now I have a string that is a direction. And I'm going to say, is that string equal to the string I'm looking for? If it is, that means that this particular room does have that exit. So I'll return true. Else, I'll go and check the next exit, right? Because we're asking a particular room from a player's perspective, the room I'm currently in. I'm saying, is there an exit in a certain direction? And that room might have a bunch of exits in it. Okay. Only once I've checked all my exits. If I'm still kicking, that means I never found an exit with a direction leading away from me. So I'll return false. So this allows us to ask a particular room, do you have an exit leading in a certain direction? So if I'm inside player here, I'm going to say if this dot current room, that is the player that this room is in, has exit line. So we know that line holds the direction we are trying to go. And then we're going to say, does the room I'm currently in, because this is from the player's perspective, we're inside the player class here. If the room I'm currently in has an exit that's equal to that line, then I want to take that exit. Else, maybe we give an error saying something like system.out.println exit not found. And then maybe we look around again or something like that, just to let them reassess their surroundings, something like that. All right, so before I write the code to take the exit here, we'll go ahead and run this. Oh, it's showing me your the error. I left the semicolon in there. All right. All right. So I'm not going to say look, I'm not going to say exit, but I'm also going to put in a bad direction. I'm going to try to go to the south. It's going to yell at me, say, hey, exit's not found. Here, this is the room you're in. Why don't you try again? Okay. But now we're going to have to do the version of, hey, if I did type in north, so for instance, if I type in north here, we're not going to get that whole not found thing. It definitely got into that if where it's like, okay, there is an exit that direction. Now we need to actually take that exit. All right. So go ahead and I'll just type in exit here and get out of here. So we'll go into room. So now we know the room has an exit. So now what we want to do is we want to take an exit from that room. All right, it's going to be some similar logic instead of returning a true or false, whether or not it has the exit, it's going to just accomplish a task. And the task it's going to accomplish, if I'm standing in this current room and I take the exit to the south, what should happen? I should leave this room, which means that I'm no longer in this room. So from my perspective, my current room is nothing. And this room also forgets about me. Because remember, rooms keep track of the current player that's in there. So this room's going to forget that I'm in here. And then we're going to set my new current room equal to that room and let that room know about me. And if you remember here, we have add player. So when we add a player to the room, that function tells the room to remember the current player and go ahead and let that player know about the room they just got added to. Make sense? So what we're going to do is for a room, we're going to have a version of, this guy's going to be void. This guy's going to be called take exit. Take a direction as a parameter. And we're going to do something pretty similar to what we did in here. So I'll just copy that for loop. We're going to go through all of our exits. Once we find an exit leading to a certain direction, we want to actually go to the room associated with that. So let's see what, so I've asked this exit to get the direction leading away from a particular room. So now we have a string. Now we need to teach an exit to give us the room at a particular destination, because that's the room I'm going to be putting myself into. So from the perspective of a player, right, that I'm sitting in this room, let's say, and I say, is there an exit to the south? Yes, there is. Okay, I want to take the exit to the south. So I'm asking that exit, this exit right here, to hand me that room, a pointer to the room next door, so that I can tell that room, well, so that I can tell this room that I'm leaving, and then add myself to that room. Make sense? All right, so I need to teach exits how to give me a room given a direction. This guy's going to return a room, get room in a direction. All right, so what I want to do is I want to ask if this dot direction leading to dest2 dot equals the direction we're looking for, and return destination 2, else return destination 1. And I still like doing the this dot, so I'll throw this dot in front of those. So we're going to assume that we've already pre-asked a room, do you have an exit in a certain direction? If so, we're going to go ahead and get the room in a direction, passing it the direction. This room will check and say, if the direction you wanted to go is equal to my direction leading to destination 2, then I will hand you destination 2, which is a room. Otherwise, I'll hand you destination 1, which is the other room. But we are assuming, this assumes that direction is a legal direction for this room. We are making that assumption with this code. If we didn't want to make that assumption, we can do that whole runtime error thing that we talked about last time, where we say, hey, look, I'm returning a room here. So I could say else if it's destination 1. So if I'm still kicking down here, we can just go ahead and put it in else if we want. I'm going to throw a new runtime exception room in that direction not found, something like that. And that will allow us to not have to return a value here. Because Java says, look, you have to return a value, or you have to start the ball rolling that something went wrong. One way or another, if you promise me you're returning a something, cover all your bases. All right, so now back in player, if a current room has an exit, we'll go ahead and get the room in that direction from our current room. Then we're going to tell our current room to forget about us. All right, because our current room we already calling, oh, that we need to tell it to take an exit, that's fine. A room has a current player. Do we have a way of we'll just write a quick function called remove player. We'll teach a room how to kick the player that's currently in there out. Public void remove player. And we'll just set the current player to null. So they are no longer in that room. Go ahead. Well, right now we only have the ability to hold one player. But you're right. Looking forward, if we're going to have multiple players in a room, and we want to remove those a certain player out of a list of players, we would have to be more precise here. Okay. So then out here in player, if we have the exit, we're going to go ahead and get the room that we want to go to. Okay, so I'll leave the code in this current state. Make sure I goes inside a player. Which get room in a direction. Didn't we just write that? Oh, no, we wrote it inside of exit. That's okay. So we taught our exit how to do that. So out here in player, I'm just going to have you write the whole thing here. This guy still runs. It does. So our homework, given this code right here as a starting point, have the player successfully take an exit, allowing them to walk around the map. Note, taking an exit means that the current room loses a player and a new room gains that player, and the player becomes aware of the new room they are in. All of those things need to happen, right? So if I leave this room and go into that room, this room forgets about me. I forget about this room. Ultimately, that room becomes aware of me, and I become aware that I'm standing in that room. Both sides of the equation have to happen. We need to be careful that one of those things, like for instance, we need to be careful that this room doesn't think I'm still in here, while at the same time I think I'm over there and that room thinks I'm over there. So from a maps perspective, two rooms think I'm in there. Make sense? Can't be in two places at once. Put a link to the code and a self assessment. All right, questions, what I'm asking you to do? So we should have this relatively set up to do this. You're gonna have to write a couple of things, but we're not talking about tons and tons of code. A couple of functions here and there, and then call them in the right order. Questions, comments, concerns, bribes? All right, I'll see everybody on Wednesday. Do pay attention to your emails. I'm guessing we're supposed to have like an ice storm later today through tomorrow. afternoon. So there's a decent chance some of your classes might be online tomorrow. So make sure you check your emails. I'm tentatively planning on doing all my classes online tomorrow because I think we're supposed to get like a half inch of ice. And that's not great. And it starts tonight around 5. So if you need to go somewhere, go before 5. This is the punchline. All right, everybody, have a good one. Be safe.